Jai Hind to all of you. I am Dr. Himani Garg, professor at Ajay Kumar Garg Engineering College, Ghaziabad, and today I am going to discuss about digital modulation schemes. This is in continuation with my last lecture in which I had discussed about one of the digital modulation technique called ASK, amplitude shift keying. Now, we all know that modulation is a very important thing for the transmission of signal over a longer distance, in which we are having two signals. One is the message signal and another is the carrier. Generally, carrier is a high frequency signal which is being transmitted to a longer distance for communicating our message to the receiver. Now, modulation is defined as a process by which some characteristics of a carrier is varied in accordance with the modulating wave. Now, in modulating wave, the message, we are having the parameters like amplitude, frequency and phase. So, using these parameters, we can have different types of modulation schemes. The message as a result of pulse digit modulation is termed as digital message. We have discussed about modulation, digital modulation techniques like pulse amplitude modulation, frequency modulation, PPM, PWM, but they are of a very low frequency. They can't be transmitted as it is. They have been modulated in the digital form, but they are of a low frequency. There is in the baseband range, but we have to transmit, then we will have to need a continuous signal that is of a very high frequency. That means the carrier should be of high frequency. So, this digital message is still in the baseband range, that is digital signal. Direct transmission of such messages over long distances via high frequency channel is not possible. Channel is of a very high frequency. In digital communications, the modulating signal consists of binary data or an M-array encoded version of it, and the carrier is sinusoidal. The foremost thing to remember in this is that the carrier here is sinusoidal. The carrier will be carrying our message signal. Message is digital, but carrier is sinusoidal. When we talk about different types of digital modulation schemes, they can be categorized as coherent and non-coherent. Coherent, they are synchronous. Transmitter and receiver both are working at the same clock, whereas in non-coherent, we are not clear that whether the transmitter and receiver are working at the same clock. So, we are having binary, that is where we are having M is equal to 2, bits will be 2, ASK, FSK, PSK, amplitude shift keying, frequency shift keying, phase shift keying. M array ASK, M array FSK, M array PSK, M can be any term. The hybrid, so as to make the foremost use of different techniques, every technique ASK, FSK, PSK having its own advantages and disadvantages. So, that is why we are having the hybrid techniques that make the best use of the mixing of these techniques like amplitude phase shift keying, quadrature amplitude modulation. So, we are making use of mixing of these basic three techniques. So, the non-coherent also includes these, but here the carrier will not be synchronized. Now, what is this frequency shift keying? Is a digital modulation technique in which the frequency of the carrier signal varies according to the digital signal changes. FSK is a scheme of frequency modulation. So, in FSK, the carrier, what will be changing, but where will be the change? The change will be in the frequency. In the amplitude shift keying, message was present whether the carrier was present or there was no carrier. But in this case, we are having the carrier at all the instants, but the carrier will be of different frequencies at different instants depending upon our digital bits 1 and 0. The output of FSK modulated wave is high in the frequency for a binary high input. Means if we are having 1, then binary input is 1, that means high frequency is to be transmitted, and low in frequency for a binary low input. If 0 is there, then low frequency is to be transmitted. That means carrier is always present, not in the as in the case of ASK where carrier was present, not present, carrier not present, two carriers will be present. The binary ones and zeros are called mark and space frequencies. Mark and space frequencies. The following image is the diagrammatic representation of FSK modulated waveform along with the input. So, you can see here directly we are having FSK of the carrier signal is varied, frequency of the carrier representing on 1 and 0. So, you can see here also in the earlier amplitude shift keying we were having two amplitudes A0 and A1. A0 that can be 0 and A1 can be 1, and the frequency here was FC, means carrier frequency, that was same for both this for binary 0 and 1. Here we are having two frequencies, one is frequency F1, another is frequency F2. So if binary 1 is to be transmitted, let's suppose I have to transmit to 1, then which carrier will be transmitted? This F2 carrier will be transmitted. F2 carrier will be transmitted, and if 0 is to be transmitted, then F1 signal will be transmitted. So that means two types of carriers will be there. This is shown in the form of this diagram also. For 1, you can see high frequency carrier is there. For 0, the frequency is somewhat low, high frequency, and then low frequency, then high frequency. And generally for F1, for 1, we will be keeping high frequency, for 0, we will be having low frequency. Now, coming to the demodulation part, demodulator must be able to determine which of the two possible frequencies is present at a given time. So, if we are able to know that F2 is present at a particular time, we are having a receiver and we are able to receive the signal F2. That means which signal has been transmitted? If F2 we are receiving, that means binary 1 has been transmitted. If we are receiving F1, that means 0 has been transmitted from the transmitter end. So, demodulation generally looks for the frequencies, that whether F2 is being received or F1 is being received. Now, what is the advantage? FSK is less susceptible to errors than ASK receiver, looks for specific frequency changes over a number of intervals, so voltage spikes can be ignored. So, we say that frequency noise mainly affects the amplitude of the signal, and here the amplitude remains constant, the variations are only in frequency. So, we say that the noise factor will be less in this case. Now, what will be the disadvantage? FSK spectrum is double that of ASK. This is it will be taking more bandwidth, consuming more bandwidth than ASK. So, this comes with a disadvantage. Now, what is the application? Over voice lines, high frequency radio transmission. You must have heard FM transmitter in our car. We generally listen to the FM radio. So, this is the same FM modulation that is being used. So, over voice lines, for voice signals we are using this. Now, frequency shifting, now this will be more clear to you. This is a message signal 1010 input binary sequence. For F1 there are two frequencies, F1 and F2. Depending upon the signal digital bits, we are having 1 and 0 that is being transmitted. FSK, now coming to the block diagram of FSK, that how now we know that how FSK signal looks like. Now, we will see the technique by which this FSK modulation will take place. You can see this is, there are, as we have said earlier, that there are two frequencies. So, there will be two oscillators, one oscillator 1 and oscillator 2. Oscillator 1 is producing frequency F1, oscillator 2 is sending frequency F2, and this is the message signal. Message here can be one digit, in the message is in the form of digital form 1 and 0. And this message signal is controlling the position of the switch. If, for example, here 1 is there, then it will be, then the switch will be coming to this relay, will be connected to here, and oscillator 2 will work and will give the frequency. If 0 is there, then oscillator 1 will be working and it will be giving the output. So, in this way, with the help of a simple switch, we can have shift from one frequency to another frequency depending upon our digital bit, either going to 1 or 0, and ultimately we will get FSK modulated wave. So, this is the explanation of the same diagram. The two oscillators producing a higher and lower frequencies are connected to a switch along with an internal clock. To avoid the abrupt phase discontinuous of the output waveform during the transmission of the message, a clock is applied to both the oscillators internally. The oscillators, both the oscillators are working at a particular clock, so that there is no abrupt changes there. The binary input sequence is applied to the transmitter so as to choose the frequencies according to the binary input. So, if binary input 1 is there, which frequency will be selected? F2 frequency will be selected. If 0 binary is there, then F1 frequency will be selected. Now, if now coming to the modulation has been done, now at the receiver we are getting two frequencies. F1, F2, F1, F2, F1, F2 depending upon the bits. Now we have to retrieve that bits from that different frequencies. So for demodulation, what are the different steps? There are different methods for demodulation of FSK wave. The main method of FSK demodulation are asynchronous detector and synchronous. We have explained again and again what is the difference between synchronous and asynchronous. The synchronous detector is a coherent one, while asynchronous detector is a non-coherent. So firstly we will discuss about the asynchronous FSK demodulation. The block diagram of ASK demodulator consists of two band pass filter. We are working with frequencies. We are having two frequencies, F1 and F2. For at the demodulator end, obviously there will be a filter. There will be filters that will be taking out the frequency F1 and F2. They will be filtering out these two frequencies. Two band pass filters, two envelope detectors, and a decision circuit. This is a block diagram. You can see here. You can see you are having the FSK. Now the FSK comprises of both the frequencies F1 and F2. Two frequencies are there. Both are, now these two filters will be, for example, this one is tuned to filter frequency F1 and this is tuned to frequency F2. So whatever the mixed signal comprising of F1 and F2 will be applied to this band pass filter. It will filter out the frequency F1. This will filter out the frequency F2. So now at this particular end we are having a signal having frequency F1. This is having a signal having frequency F2. This is given to the envelope detector. Envelope detector will detect the envelope of the signal. From this we have to check whether 1 is being transmitted or 0 is being transmitted. From this envelope detector we will get the actual picture of 1 and 0. Then the decision circuit will ultimately decide if the signal is above threshold or below threshold, that either 1 was being transmitted or 0 was being transmitted. At the output we will get FSK demodulated signal. So this is the ASK, asynchronous. Why it is asynchronous? Now you can see at the receiver end there is no oscillator, no carrier is being generated. So that means that transmitter and receiver both are not synchronized. That's why it is called asynchronous. The FSK signal is passed through two band pass filters tuned at two different frequencies. As I have told you, F1 and F2. The output from these two band pass filters look like ASK signal. Now we are having the amplitude signal is there. We are only having the amplitude signal which is given to the envelope detector. The signal in each envelope detector is modulated asynchronously because there is no carrier. The decision circuit chooses which output is more likely and selects it from any one of the envelope detector. It also shapes the waveform to a rectangular. It gives the rectangular waveform. Now coming to the next type of FSK demodulator, that is the synchronous. Synchronous demodulator consists of two mixers with local oscillator circuits. Now comes in picture the local oscillator generating the frequency FC, F1 and F2. Why? Because they are synchronized to the transmitter. Two band pass filter and a decision circuit. The things will be more clear with this diagram. You can see the same type of diagram that we have discussed earlier, but here the difference is we are having oscillator. Our message signal will be multiplied, this received signal will be multiplied by this carrier. Here also it will be multiplied with the carrier. Then it will be applied to the band pass filter. Band pass filter will select only F1 or F2 and ultimately it will be given to the decision circuitry so as to get the output. Here the difference comes with the carrier, generation of carrier. The FSK signal is given to the two mixers with local oscillators. These two are connected to two band pass filter. These combinations act as demodulators and the decision circuit chooses which output is more likely and selects it from any one of the detectors. The two signals have a minimum frequency separation. For both the demodulators, the bandwidth of each of them depends upon their bit rate. This synchronous demodulation is a bit complex than asynchronous because here we are having another component called carrier oscillator. So today we discussed about frequency in digital modulation schemes. We discussed about frequency shift keying. We discussed about the asynchronous and synchronous frequency shift keying. We also discussed about the generation, modulation, that means, and demodulation of FSK. So that's all for today. We will continue with another digital modulation techniques in the next lecture. Thank you for watching.